Welcome everyone to the second session in our track A. This time we're talking about data migration in the Hadoop world, and we have two fantastic speakers with us today. I'll briefly introduce them, and then I want to hand it over to them. Before we begin the session, just a few notes on our virtual platform. If you haven't engaged with it just yet, there's a chat window to the right of the video player, and you can chat along with other attendees about what you're hearing and seeing in the session, or even in the conference in general. You can also post any questions in the chat, and then we'll take them and we'll pass them along to the speaker once they are done with their presentation. If you see any technical issues on your end, also let us know. We'll do our best to address them. And we encourage you to visit our networking area after the session is done. Some of the speakers will be there, and you'll be able to connect with them one-on-one. So it's a fantastic place to continue the conversation that will start today. Our speakers today, first is Ken Seier. Ken is passionate about driving analytics innovation with measurable outcomes and real business value. Ken and his team have been responsible for billions of dollars of revenue and savings through the responsible analytics initiatives and innovation. Next, we have Tony Velcich. Tony is an accomplished product management and marketing leader with over 25 years of experience in the software industry. Tony is currently responsible for product marketing at OneDisco, helping to drive go-to-market strategy, content, and activities. With that being said, Tony, I hand it over to you.
Okay, great. Thanks, Ruben. And so let me share my screen here. All right. Perfect. So thanks, Ruben. Thanks for that introduction, and thank you everyone for joining us today. Looking forward to presenting to you guys, and then even the Q&A after. So Ruben just went through the introductions. In terms of kind of the agenda for our session today, Ken and I are going to basically tag team the session a bit, right? So I'm going to start off with a quick introduction, kind of review of the dynamics that we see going on in the market today, why more and more organizations are migrating their on-premises Hadoop data lakes. Specifically, we're going to be talking about to the cloud and the complexity that's associated with those migrations. I'm then going to drill down into a few of the key data migration specific considerations that you should think about when planning the migration. And then Ken's going to cover the workload or the application specific migration considerations. I'll come back to talk through some of the post-migration items that you should think about and probably think about early on in your upfront planning. And then finally, I'll turn it over to Ken to wrap things up with a summary and have some time for Q&A. So I think we're all really familiar with the importance of data, right? How leading organizations are the ones that are most data driven. As a result, we've really seen a greater number of these data modernization initiatives. Organizations are doing that so they can better take advantage of really all of that data that's available to them. And usually this means migrating that data to the cloud. Listed on this slide are some of the key factors that's driving this cloud migration. And really all of them are related to enterprises modernizing their data architecture. So that's probably the overall driver of this. Companies are looking to digitize their businesses to better compete with all the new entrants that have grown up natively in the cloud. Obviously cost optimization is one of the big drivers and continues to be one of the main ones. And then really, I'd say all of the factors are related to analytics and advanced AI and machine learning, that really can be better supported in the cloud. I mean, we've seen much more innovation happening in the cloud, both by the cloud service providers themselves, as well as third-party ISVs such as Databricks and Snowflake, really making AI and ML much more better suited in the cloud, right? And then over this past year, we've seen a lot of external factors even accelerate some of this migration. Last year, organizations really found that they needed to support all of a sudden a global workforce that suddenly is entirely working remotely, and that they really needed to optimize their data and their infrastructure so that they can best support this reality. There's really been a lot written on this topic, right? One study that surveyed 500 global IT decision makers during May and June of 2020 found that 80%, agreed that the COVID-19 pandemic has or really will cause organizations to continue to accelerate their migration to the cloud. However, if we're looking at, especially the Hadoop cloud migrations, which is one of the things I'm primarily talking about here, these can be very complex. And this slide starts to talk about that complexity. First off, the bullet points there on the left-hand side really list out some of the requirements and expectations that organizations have for moving, Hadoop to the cloud. And of course, cost savings is one of the primary expectations, right? Just talked about that. The graph itself shows basically a 3-year cost for storing 1 petabyte of data on premises and the typical cost for the cloud storage of that same amount of data. And the numbers here are really based on both actually the Azure and AWS calculators that you can access on their websites. If you go there, you can plug in your own parameters, amount of data, et cetera, and it'll calculate the costs here and estimated savings. And typically, it shows, as in this case, that the cloud cost can be about half of that on premises. However, there's a lot more to this, and especially if we're talking about the migration itself, what about the migration costs? And typically what we see is enterprises will, set out a budget that, for their data migration initiatives, that's still going to result in their getting a good cost savings by moving to the cloud. However, as many analysts point out, typical data migration projects, especially those leveraging kind of some of the legacy data migration approaches or tools that are available for Hadoop, really exceed time and budget. According to the Bloor Group study cited here, 80% of data migration projects exceed their time and budget. And, obviously this can easily wipe out any potential cost savings. And this is what we at WANDisco refer to as the data migration gap. And that's kind of one of the things I'm going to be talking about. What are the key consideration points for your data migration in order to be able to manage this gap and minimize the costs and the risks associated with these migrations. So let me drill down then into identify basically kind of 3 key data migration considerations. The first really is with regards to the scale of the data to be migrated, right? So, these Hadoop implementations typically are very large, right? From hundreds of terabytes on the small end to, more common to be multiple petabytes or even tens of petabytes in size can be common. And while there's various options for migrating small data volumes, those same approaches really don't work well when you're trying to scale them up into these very large volumes and large scale migrations. But regardless of the approach, there's really one of 2 ways to transfer the actual data, right? So it can be done over the network, and you can calculate that or estimate how long that's going to take based on the network bandwidth that you have available and the volume of data that you need to move, right? So you can see from the chart here on the slide, moving 100 terabytes of data over, say, a 1 gigabit per second pipe takes about 9 days. Migrating 1 petabyte takes over 90 days. And if you're talking 10 petabytes, that's actually, again, just using a 1 gigabit per second pipe, over 2.5 years of just migrating the data. And these numbers actually assume that you're utilizing the network at 100% capacity the entire time, right? And unless you have a dedicated network for the migration, there's going to be other workloads that also need to use it, so you won't be able to use it at its full capacity. The alternative method that often gets used when you're talking about very large volumes is to use physical data transfer device. devices. Of course, actually, this also takes time, and some of the things you need to consider or use to estimate how long that might take is really there's the transfer rate at which you can copy the data onto the device. How many devices are you going to need? Again, for example, for about 1 petabyte of data, you typically are talking about 25 devices. Then there's, how long will it take to actually, ship or truck those physical devices to the cloud provider's data center? And then finally, even to the transfer rate again, to now move that, that data off of the devices and onto cloud storage. And so there's certainly things that you can do to make this process go faster, right? You have a dedicated network, you get greater bandwidth, or you can use, higher scale transfer devices. But eventually, kind of the laws of physics do come into play. I mean, migrating these large data volumes simply do take time. So you need to make sure you're planning for this up front. And that's why it's very kind of important to understand how long it'll take. The next important consideration is with regards to the amount of ongoing data changes, right? So over the years, these Hadoop environments have become actually very business critical and very active. So it's not just the sheer volume of data that adds the complexity to the migration, but really the amount of data changes that are taking place. So this includes new data continuously being ingested or existing data being, updated or deleted. The chart on this slide is actually from one of our customers. So when we measured, this customer's workloads, we measured peak loads approaching about 100,000 file system events per second. And even the average loads over the entire 24-hour period, approximately averaging about 20,000 file system events per second. So a very active Hadoop cluster. And the question is then, how do you perform data migrations when the data is actively changing like this? This issue was actually cited as the top challenge by respondents in a recent Hadoop migration survey that we conducted with DBTA together. So what we see from customers is usually they're, to deal with this change, they kind of do a few different things potentially, right? So one, they may not allow the changes to happen. However, to do this, customers are usually bringing down the production systems so that no data changes can occur. However, like we saw in the previous slide, how long it takes to migrate those large volumes of data, can you really afford to bring down the system for weeks or longer? And for most organizations, that's just really not acceptable. And I'll talk a little bit more about that even on the next slide. So the next option, or usually what we've seen followed, is folks try to develop kind of custom solutions to manage and deal with those data changes, right? They're either going to try to somehow manually reconcile all the changes, or they develop custom scripts to rescan the data, make multiple passes to look for changes, since the prior pass. But one of the things we see often is, depending again on that volume of data and the amount of changes, it may never be possible to ever fully catch up even with this approach. So eventually organizations again bring down their production environments to try and catch up with the changes. And the third option is to leverage, tools that are very specifically designed to handle data changes and that are optimized for that. That's actually what we do at WANDisco, right? We provide automated solutions that allow you to migrate data and metadata, so you can enable it to continue to change in your production environment and not impact that. So, and I think that's a very important aspect of the migration. And that being not to cause business disruption, right? So as I just mentioned, right, bringing production systems down during migration really is not acceptable for most organizations. Again, looking at the results of that recent Hadoop migration survey that we conducted, we saw over 62% indicated that either 0 or only hours of downtime was really acceptable. You can see that from the chart on the left there. almost 34% did say that days was acceptable, but almost none said, weeks or months. And actually, I'm kind of surprised that anyone said that months would be acceptable. That must not be a very critical system if you can bring it down for months and afford that level of downtime. But clearly, hours or zero downtime is really the only thing that's acceptable. The other question we asked then data architects was, what's their biggest concern regarding their planned Hadoop migration project? And the number one response, actually, as you can see from the chart on the right there, is business disruption was their biggest concern. Second on their list of primary concerns was the number of IT resources that they thought would need to be required for that migration. And that actually brings me then to the next key consideration. The third important consideration that I want to talk about is regarding kind of the number of manual processes and the amount of custom code development that's required to perform the migration, and hence the number of resources that you would need. Again, the legacy migration approaches that we see customers trying to use usually result in very significant impacts on IT resources and are the main reason that these migrations go over the time and budget, or maybe never even complete, as kind of talked about in that initial slide. The complexities of handling the on-premises data changes and the number of IT resources required to perform data migrations were cited as the biggest items that were actually impacting migration costs. So the graph on this slide, the respondents indicated how they managed to handle those changes, or how they plan to handle those changes, right? So it's a combination of both folks that have completed a migration or just planning one. And over 50% indicated that they plan to use some sort of software to automate the migration of those changes. However, even here, you have to be careful, because one of the primary tools that we see enterprises attempting to use for Hadoop data migrations is DisCP, right? Distributed copy. DisCP is actually a free tool that's included with the Hadoop distribution. And so that's typically why most organizations attempt to use it first. However, while the tool is free, like the slide says on here, there's really no free lunch. I mean, DisCP was designed for, inter or intra-cluster copy of data at a specific point in time, right? So it's really not designed to handle migration of ongoing data changes. It's really essentially meant to copy static data. In order to handle changing data, that requires kind of what we talked about earlier, and organizations to develop custom code or scripts around DisCP, even to perform multiple passes of that source data to handle that change. And enterprises often are very surprised at the complexities of handling, and developing these custom programs and the number of resources that are required to do that and then to maintain them. The automated migrations really provide a better option, right? If it's specifically designed to handle migration of changing data, it allows your production systems to continue to operate normally, no downtime, no disruption, and really minimize the overall impact on IT resources. And this is an important point, because I think it allows your resources, or the SI folks like Insight, which Ken is going to talk about in just a second, to really focus on the workload migrations, right? Or developing new I and ML innovations, and not worry about that data migration code. And with that, Ken, I'm going to turn it over to you and let you talk about the key workload migration considerations.
Great, thank you, Tony. So Tony's done a great job of outlining some of the challenges and complexity. For the past several years, Insight has been working with organizations all around the globe in a variety of industries to help accelerate their cloud migration of this crucial big data infrastructure. Like Tony said, the big data infrastructure that was traditionally built on-prem has really become a keystone of their analytics capability for big data and analytics across both their business and their customer-facing, their business lines. But over time, it becomes very expensive to maintain on-prem, especially as you have to do multiple hardware refreshes, and it becomes very brittle. The way that on-prem clusters are built and optimized becomes a real challenge. And these organizations become really challenged to grow their analytics capability quickly, to implement new capabilities, or just to expand the capacity of these clusters because of that hardware-bound on-prem environment. So we work with customers in order to accelerate their move to the cloud using WAN-Disco and some other techniques and tools that we've built. Part of the challenge comes in just the complexity of these workloads. Usually on-prem, there's a certain cluster size. These clusters have been highly optimized, maybe over-optimized, where different tools are installed on different nodes and have different relationships and priorities, and the jobs are heavily scheduled and highly optimized in order to maximize that CPU throughput. There's usually a variety of legacy tooling, Hive, HBase, Phoenix, things that go back several years that are still working, so you don't want to change it necessarily, but at the same time, they're not extensible. They're not something that's going to be able to grow with your business, and they need to be modernized. Those jobs are highly optimized in that scheduler, and it's highly optimized based on the fixed cluster size. And often there's custom implementations in edge nodes and security protocols that make it really hard to move to the cloud. Next slide. So what we want to do is we want to reduce that complexity and that risk. But there's often not time to refactor. As Tony was saying, the downtime required is usually measured in days or less. There's a real complexity around that data concurrency. That you do a big batch update and then you try to do those incremental updates. You try to hand roll it. And it usually doesn't work the way you expect. Unless you have some really mature tooling to help you automate that entire process, your engineering team spends way more time managing the data updates than they do being able to focus on the actual migration. This puts risk, this puts strain, and this puts additional cost onto your migration, which you don't want. A lot of companies, in order to avoid that, will do a rehost. So this is a VM to VM, on-prem to cloud copy of this complex infrastructure. This has a very low risk, but it doesn't allow you to capture the cloud benefits, and it postpones the capture of that real cost savings and optimization that comes from using cloud tooling and elasticity. There's a middle ground around replatforming where maybe you move your on-prem infrastructure to the cloud, but you figure out how to tie it in with cloud DevOps in order to do your scaling, your automation, your security. But that usually takes a long time to implement. The tools are still catching up. And there's usually things around your big data infrastructure, like maybe your ETL tooling or your data pipelining tooling or a streaming tool that's not in that big data cluster that has a hard time making that jump to the cloud. Where you want to get to is that refactor, where you're using those scalable cloud resources, where everything is pennies and pennies, where everything is elastically growing or shrinking with that demand, where you can run your jobs not when you have CPU, not at 3:30 p.m. or 3:30 a.m. on a Sunday, but when you need the job to run and know that the infrastructure is going to scale with you. But that often requires taking those legacy tools and modernizing them. That's a longer road. There is some automation available. We have some tools available, but we still have to get in there and handcraft and validate. So we can't do that in a couple of days. So either we stick with that lift and shift approach, minimize our risk, and don't capture benefit, or we push really hard, work really hard, do a lot of hand-rolled work, and then get to the cloud and hope we did it right. We don't want to do that at all. So how about the next slide? So what we want to do is implement blue-green deployments. This is a common pattern in DevOps where you have two simultaneous environments where you can flip back and forth freely. One would be on-prem in this case, the existing cluster, and the other would be in the cloud, but a refactored cluster using all best practices and cloud-based tools. You migrate workload by workload, workload 1, workload 2, maybe this is by business area like finance, maybe this is by certain tooling like you want to retire Hive, whatever it happens to be. Workload by workload, you migrate, and then there's a routing in between that allows you to flip back and forth. You can go to the new cluster or the old cluster, the new environment or the old environment. By building those workloads side by side, you gain the benefit of being able to compare them for 30 days, 60 days, 90 days, 180 days, whatever's required for you to be sure that those workloads are working correctly before you do your changeover. That workload by workload allows you to prioritize and get benefit, but it also means that if you move, say, finance over and finance is begging for new functionality, you can just start adding that once you've migrated finance into the cloud, even if 30, 80, 90% of your workloads are still on-prem. It gives you a lot more flexibility and it allows you to capture new value. That's really, really rare in cloud migrations like this, where you can immediately capture new value before the cloud migration's even completed. And it gives you a complete failback. If you find that there is an error with some of your transformations in the cloud, if you didn't do 100% QA and you need to flip it back, the finance says, no, we need to go back to the old system. The old system is right there waiting for you so that you don't have to retire that old system until you are 100% certain that your cloud migration is done. By being able to keep the data concurrent, that allows us to do this blue-green pattern. Without that data concurrency, when we have to do that big bang, there's just no way to mitigate that risk fully. Here, you have that slow, incremental, lower risk, validatable approach that we're really excited to be able to offer to our customers. Big data migrations have been on hold for many years because of their essential nature and their high risk. This de-risks those migrations, allows us to capture that cloud benefit, not in the future, but immediately, and enables new development so quickly that it really transforms the way our customers approach their big data infrastructure. Back to you, Tony.
Tony, you're muted.
Okay, sorry about that. Thanks, Ken. All right, so let's talk a little bit about the post-migration considerations. Actually, it's really a good lead-in to what Ken just talked about is a good lead-in for this, because it's really something that you need to consider, I think, early on, not necessarily just post-migration. But one of the things that I did want to talk about is, we asked survey respondents again in that survey that we conducted, what do they plan to do with their on-premises Hadoop environment? I mean, 21% did indicate that they wanted to shut down their on-prem Hadoop environment as soon as possible. However, 42% indicated that they would maintain a hybrid environment for the next 1 to 3 years, and another 36% said that they would continue to maintain their on-prem environment indefinitely. I think that's, just shows kind of the importance of having a hybrid environment capabilities, and I think really works together with what Ken just talked about in that kind of blue-green migration strategy, right? So being able to have both work together for a period of time, because these migrations take time. So being able to do them incrementally and not be forced to try to do a big bang and just shut everything completely off, because that introduces a lot of risk. And that seems to be, what folks are thinking about. We also even asked them about their plans for kind of multiple cloud environments, and 58% indicated, yeah, they plan to use multi-cloud or multiple, cloud service providers. Only 23% said no. That's actually consistent with kind of what we see going on today. I mean, many analysts that we talk to indicate that 80% of organizations are already using multiple cloud providers. However, they tend to be using them for completely independent applications, right? They don't really share data between cloud providers today. But that's one of the things we do see changing, and this slide talks a little bit about that bottom kind of right-hand chart. We asked them, do you plan to share data across clouds? And almost 42% actually indicated that they plan to do that. So I think that's a shift that we're seeing. And once you have these requirements for hybrid and multi-cloud environments, you need to ask yourself, how am I going to handle those data changes across environments? And again, that's one of the things WANDisco, provides, is the ability to handle replication across multiple distributed environments, and use our distributed coordination engine to kind of ensure 100% consistency across those. And I think that's an important factor, not only in the migration, but in the ongoing kind of ideal implementation that you may have. So with that, Ken, I'll turn it back over to you. You want to sum up kind of what we talked about today?
Yeah, thanks. Next slide. So what we've learned in our years of experience helping our customers migrate to the cloud is that the data migration is the linchpin of success. The ability to smoothly migrate the data from your on-prem environment to the cloud and to maintain its concurrency as you're affecting the workload by workload migration is essential. It is harder than it appears. It is more error prone and more fragile when you have to use the off-the-shelf or open source tools or when you have to hand roll your scripts. What we want to do is automate that away and make sure that it's flowing smoothly so that the engineers can focus on getting to that refactor that allows you to capture that cloud benefit. We know that the data concurrency absolutely dictates the solution path and how effective and fast we can be. And that those benefits, once you are doing that refactor first, you can start capturing new functionality and new analytics almost immediately and taking advantage of whatever cloud ecosystem you happen to be. And that blue-green deployment, by being able to maintain that data in both locations and go workload by workload, validate side by side, and accelerate your visible success, makes a huge difference in the overall success of the initiative within your organization, but it also makes a huge difference in terms of reducing that risk and making sure that you're maintaining a high quality of analytics throughout that migration process. So we've been really pleased to talk to you today. Thank you so much for your time. We'd love to take any questions that you might have, and Tony and I will be around for a little bit.
Perfect. Thank you both. So we do have a few minutes here for questions. So if you have any, put them in the chat and we'll do our best to get to them. But I do have some questions to start here for either of you. First question, how do you recommend technical teams properly manage expectations when undertaking these projects? There might be some conflict in what a business executive might expect of how long this might take, how easy it might be, or how much it might cost.
Sure. I think that expectation setting is a big part of any project success that's going to take more than a week. So what we want to do is lay out a really clear roadmap and benchmarks for success. We want to be talking about different dates and what kind of success there'll be and to make it measurable. I can really recommend using any sort of true agile methodology, knowing that things are going to change. They're going to be unforeseen events. You can put a little padding in. One of the big challenges, though, is that these migrations are often driven by a licensing choice, and there is a hard deadline. So what you want to be is super smart about your planning, working with those executives ahead of time to say, hey, how are we going to do this? When are our licenses up? But especially working back from those critical dates to say, what is the bare minimum benchmark of success and how quickly can we get there, knowing that there may be other lower priority workloads perhaps or legacy workloads that can be deprioritized. So it's about being super smart, super communicative, and constantly talking to your sponsors to make sure they really understand those complexities and they're all laid on the table initially. They don't always like to hear them, but it's important to have that open, honest communication.
Yeah, absolutely. I couldn't agree more. Probably not too much to add, but setting expectations, absolutely key. I think the other piece is if you can do some upfront planning to find ways that you can incrementally shut things off and not try to do that big bang and being able to shut off portions if you do have some hard deadlines and identifying those up front. But absolutely key to kind of estimate how long it's going to take and make sure expectations are set is critical.
Yeah, I imagine it might seem a little bit like a black box or a bit like magic, when all this data gets transferred and you don't really see the behind the scenes, but there's quite a bit of work that has to go into making sure it happens properly. Okay, next question here. Even after you work with teams in this kind of migration projects, what are the things that you still see them consistently underestimate when undertaking a project like this, even after you sort of walk them through what might happen?
So we work with a number of extremely talented teams all around the world. They know their clusters, they know their tools, they know how to get business value out. They don't know how to do a migration because people only do one or two in their lives. So migrations are different. Migrations are harder, and there are things on that road that you just don't see coming ahead. So they say, we've got this. And we say, okay. And then 6 weeks later, they call us up and say, we don't have this. And we said, we would have liked to have done this 6 weeks ago. It takes practice. So there are certain things within business that is great for the business to own. And there are certain things within business that it's great to bring in someone from the outside who might have more experience. So when you're building something for the first time, when you're doing a migration, when you're in a new environment, when everything is new, you want to reduce that risk by bringing someone onto the team who's done it before, who has a process, who knows how to do it. And we're always happy to help.
Yeah. Yeah, one thing, just if I can add on, again, the data specific migration part of it, yeah, we, like Ken, like you said up front, I mean, we're dealing with very, knowledgeable experts, very strong, deep technical expertise. And many of them are used to using some of the tools, like, again, within Hadoop, DCP I mentioned earlier, right? So they figure that they can build that on their own, leveraging that tool, or they've used it to copy, but they really underestimate the complexities when you're trying to deal with changing data and how they really are going to handle that. And oftentimes we come in after the fact where they've been using DCP for a while, or trying to make it work for their changing data, and struggle with it. And then there are, there's definitely those organizations who understand up front how their resources are better utilized doing other things rather than trying to build custom migration scripts. So but that's kind of the big thing that we see all the time.
Great. So we do have time for one more question here before we finish in a few minutes. We'll finish on time. What do you think is the future of this kind of migration projects? Maybe what are some of the technology that you see coming down the pipeline, or changing in processes, or whatever you think will a migration of this project look like in 5 years?
So two main things. One, I think that right now we're talking about migration of legacy on-prem systems to the cloud, but what we're really going to be talking about in the future is workloads in the cloud, hybridized across the clouds, that are using replicated data and optimizing spend based on where the compute and the consumers are. So that's going to change the complexion. Instead of a one-time migration or a one-way concurrency, this is going to be a peer-to-peer networked solution. And I know that Tony and team are already at least 2 steps ahead on that one.
Yeah. I mean, absolutely. We're in total agreement in terms of where we think it's headed. Yeah, I mean, it's clearly it's that one-way migration right now, but what we see going on is, multiple different cloud providers involved, right? Not just even distributing applications across regions within a single cloud, but being able to share data and, optimize given for the, the strengths of that cloud providers, and have different workloads happening in different clouds, but where you are sharing data effectively, and how you keep that consistent across all those environments is a challenge, and that's what we're looking to solve too. So, yeah.
Fantastic. So we'll finish Q&A there. Any final comments from either of you, Tony or Ken?
No, thank you for your time today.
Yeah, no, I think we've covered it all. I enjoyed it. Thanks.
All right. Thank you, everyone. Just to remind you, our next session in our track will be about data warehouse. We'll be starting that in about 20 minutes. So be sure to check that out. Also, make sure to explore the networking area and the virtual platform we have set up. Some of the speakers will be there. You can connect with them one-on-one. And one final thank you to Ken and Tony for the fantastic presentation.